In the last video, we have seen when the branch is unconditional, then the branch is always taken and hence there is wastage of CPU cycle. Now suppose I2 is a conditional branch instruction. In cycle 1, we fetched I1. In cycle 2, we fetched I2 and decoded I1. In cycle 3, we executed I1, decoded I2 and fetched I3. In cycle 4, we write back I1, executed I2, decoded I3 and fetched I4. Suppose the condition will be evaluated and the branch target will be decided at the end of the execution stage of the pipeline. So once the execution of I2 is over, it was realized that the condition is true, means the branch should be taken to the instruction I7. So the next instruction to be executed is I7. By that time we have fetched and decoded I3. Also we have fetched I4. All these operations have become a wait. We need to flush all these instructions out from the pipeline. Should refill the pipeline with the instruction I7. And since the branch target is decided in stage 3, we can get the next instruction processed out with 3 cycles. And from then on each instruction can be processed out in one cycle. So for a unconditional branch instruction, there is always the wastage of CPU cycles, and for a conditional branch instruction, if the condition is evaluated to be true, then the branch should be taken, there is wastage of CPU cycle. The effective CPI can increase. Now, what if the condition is evaluated to be false? In cycle 1, we fetched I1. In cycle 2, we decoded I1, fetched I2. In cycle 3, we executed I1, decoded I2, fetched I3. In cycle 4, we write back I1, executed I2, decoded I3, and fetched I4. And once the execution stage of I2 is over, suppose it was realized that the condition is false, means we need not take a branch to the target instruction I7. We can continue with this normal sequence and we already have these instructions in our pipeline. We can continue with those instructions, hence there is no branch penalty, no wastage of CPU cycle. Each instruction can be processed out in one cycle each. The effective CPI will be maintained as 1. So for a conditional branch instruction, if we keep on overlapping the instructions in a normal way and if the condition is evaluated to be false, then there is no wastage of CPU cycle. The effective CPI remains 1. But consider this case. In cycle 1, we fetched instruction I1. In cycle 2, we decoded I1 and fetched I2. Suppose by some means, in the beginning itself, it was realized that I2 is a conditional branch instruction. So from then on, we do not overlap the instructions in a normal pipeline way. We never fetch the next instruction. We stall the pipeline and wait for I2 execution to be completed to identify what is the target instruction. And once the execution stage of I2 is over, suppose it was realized that the condition is false, mean we need not make a branch or a jump to the target instruction I7. We can continue with the instructions I3 and I4, but we haven't fetched I3 and I4 into our pipeline. Now we should fill the pipeline with the instructions I3 and I4 in the coming cycle. As a result, we have the wastage of CPU cycle. The effective CPI will increase, similar to the case where the branch is taken. So for a conditional branch instruction, if you are not overlapping the instructions in a normal pipeline way, even if the condition is evaluated to be false, then there is wastage of CPU cycle. The effective CPI will increase. So overall, the wastage of CPU cycle, the effective CPI, and the branch penalty, it all depends upon the percentage of branch instructions in the program and whether the branch instructions are conditional or unconditional, and among the conditional branches, whether they are taken or not. And are we overlapping the instructions in a normal pipeline way? And moreover, the stage at which the branch target will be decided. Suppose we have a set of 100 instructions. Among them, let 30 be branch instructions and 70 be non-branch instruction. Among the branch instructions, suppose 15 are unconditional branches and remaining 15 are conditional branches. For the unconditional branches, suppose the branch target will be decided in the decode stage of the pipeline. Among the 15 conditional branches, some are taken and some are not taken. The condition will be evaluated and the branch target will be decided in the execution stage of the pipeline. Suppose 10 are not taken branches and 5 are not taken branches. Now, what is the effective clock per instruction? We have 100 instructions, 70 are non-branch instructions, 15 are unconditional branches, 10 are taken conditional branches and 5 are not taken conditional branches. And the unconditional branches are always taken and hence there is always wastage of CPU cycle. So there will be 15 instructions processed out in 2 cycles because the branch target is decided in stage 2. Thus 15 instructions are processed out with 2 cycles. And for the conditional branches, if the branch is taken, then there is wastage of CPU cycle. There are 10 such branch instructions, hence 10 instructions will be processed out in 3 cycles because here the branch target is decided in stage 3. Thus 10 instructions processed out in 3 cycles. Suppose we keep on overlapping the instructions in normal way. So if the condition is evaluated to be false, if the branch is not taken, then there is no wastage of CPU cycle. So all these 5 instructions are processed out with 1 cycle each. And these 70 instructions are processed out with 1 cycle each. So total, how many cycles are required for the 100 instructions? 15 into 2 plus 10 into 3 plus 5 into 1 plus 70 into 1. 135 cycles for 100 instructions. Hence, per instruction, the clock effective CPI is 1.35. In other words, we can say all the 100 instructions need 1 cycle for execution. Some of the instructions need some extra cycle. These unconditional, because of the 15 unconditional branches, there are 15 instructions which require an extra cycle of 1. The branch target is computed in stage 2. Thus, the extra cycle required is 2 minus 1. Thus, there are 15 instructions which need an extra 1 cycle. Similarly, the conditional branches, if they are taken, they need an extra cycle of 2 because the branch target is decided in stage 3. So there are 10 instructions which need an extra cycle of 2. Remaining all the instructions need only this one cycle. So all the 100 instructions require one cycle. Among them 15 instructions need one extra cycle and among them 10 instructions need two extra cycles. So total 135 cycles for 100 instructions. Per instruction it is 1.35. The effective CPI is 1.35.